Astronomers have uncovered another stellar stream hiding deep in the Milky Way Galaxy. Stellar streams are created as the Milky Way Galaxy cannibalizes dwarf satellite galaxies, gravitationally ripping streams of gas and stars from the smaller galaxies as they get too close. The process, known as galactic cannibalism, is how galaxies grow by devouring smaller galaxies or merging into bigger ones. It's a messy process, with tidal tails of stars and gas on one or both sides of these galaxies during the encounters. And it's happening right now. Our Milky Way Galaxy is cannibalizing several smaller galaxies, including the Large and Small Magellanic Clouds, a pair of dwarf galaxies visible in the southern skies, as well as the Sagittarius dwarf galaxy, which is making what could be its third pass through the disk of the Milky Way on the other side of our galaxy, and losing more and more stars with each pass. In fact, the Sagittarius stream is the most direct evidence of this cosmic encounter. Interestingly, so far, astronomers have found far more streams in the Milky Way generated by globular clusters compared to those generated by dwarf galaxies. Globular clusters are tight balls of stars, often containing several thousand to several million stars, all gravitationally bound closely together. They're thought to have either been formed at the same time in the same molecular gas and dust cloud, or alternatively, they're the remnant inner cores of galaxies that have already been torn apart by the Milky Way. Recently, data from the European Space Agency's Gaia spacecraft has identified a new stellar stream from a dwarf galaxy in the Milky Way. The new discovery, reported in the Astrophysical Journal Letters, was achieved by astronomers using an algorithm called Stream Scanner, which is based on a match filter method. The study's lead author, Yang Yong from the Chinese Academy of Sciences, says the algorithm is designed to detect streams by combining proper motions of stars and photometry from Gaia. The authors have named the new stream the Yangtze. Yong says the Yangtze is now proven not to be an artificial signal based on interstellar excitation and the Gaia Data Release 3 scanning pattern. It was measured to have a width of about 1.9 degrees across the sky and a length of 27 degrees on the sky. It's located some 29,745.46 light-years from Earth. The average age of stars in the Yangtze stream is thought to be about 11 billion years, which could be close to the age of the Milky Way itself. So this is a very ancient artifact. The authors also tried to understand whether Yangtze was associated with other known streams and globular clusters in the Milky Way. They found that the Palomar 1 stream was near to the Yangtze in angular momentum and energy space, and the anticenter stream was almost on the same orbit as the Yangtze. So the dynamics and metallicity estimate suggests that the Yangtze may be closely related to the Palomar 1 globular star cluster and the anticenter stream, which is thought to be the remains of a gravitational tidal tail caused by the Sagittarius dwarf galaxy's first passage through the disk of the Milky Way. Studying dwarf galaxy debris streams provide astronomers with key materials to reveal the galactic structure and evolution of the Milky Way, and so the Yangtze should be helpful in further studying the merger history of our own galaxy. This is SpaceTime.